Welcome to The Explainer. Today, we're going to crack open a barrel of crude oil and take a journey from top to bottom to really understand how this raw gunk gets transformed into the stuff that powers our entire world. You know, if you just had a barrel of crude oil sitting there, it's pretty much useless. It's just thick, sludgy black liquid. So, how in the world does this stuff power, everything? The magic, of course, happens inside a refinery, and that's the journey we're on today, from the lightest fuels at the top to the heaviest gunk at the bottom.
Okay, so to understand any of this, you have to get one key concept, the crack spread. It sounds a little weird, I know, but it's actually pretty simple. It's the refiner's profit margin. Think of it as the difference between what they pay for that raw crude and what they can sell all the finished products for. This number, this spread, is the economic signal that dictates every single move a refinery makes.
All right, let's get into it. We're going to start our journey right at the very top of the barrel, with the product that, let's be honest, we're all most familiar with, gasoline.
And here's the first thing you absolutely have to understand. Gasoline isn't just one thing. It's not like you just boil the oil and skim gasoline off the top. No. It's more like a high-tech cocktail. It's a carefully constructed blend. Refiners are like master chemists, mixing a bunch of different components to hit some insanely precise targets.
And this is where it gets really wild. I mean, look at all this. It's a massive multi-dimensional puzzle they're solving in real time. They've got to nail the octane level so your engine runs smoothly. They have to manage vapor pressure, which actually has to change with the seasons. Then there's sulfur, aromatics, oxygenates. It's this incredible balancing act, and they have to get all of it right, all at the same time.
So, what does all that complexity actually mean? It means gasoline becomes what the industry calls the pivot product. Because it's so valuable and so complicated to make, its economics basically run the whole show. The price of gasoline, day in and day out, is what drives the short-term decisions for the entire refinery.
Okay, so that's the top. Now, let's move down a bit, into the middle of the barrel. And this is where we find the real workhorses of the global economy. But what's fascinating is there are two of them, and they couldn't be more different.
First up, you've got jet fuel. And the one word you need to remember here is rigidity. I mean, think about it. When you're 30,000 feet in the air, you don't want the fuel to be kinda right. The specifications for things like its freezing point are absolutely non-negotiable. There's zero room for error. Safety is everything, which makes producing jet fuel a really inflexible process. And then you have diesel, a totally different story. If jet fuel is the rigid specialist, diesel is the powerhouse. This is the stuff that literally moves the world. We're talking trucks, trains, cargo ships, tractors, construction equipment. The demand for diesel isn't about the summer driving season. It's a direct pulse on the health of the entire global economy. When goods are moving, diesel demand is strong. It's that simple. So you see the stark contrast, right? On one hand, you have jet fuel, the super specialized, inflexible product where safety is the only thing that matters. And on the other, you have diesel, the flexible, globally traded giant that acts as the balancing mechanism for the whole system. When there's a surplus or a shortage somewhere, diesel is often the product that clears the market. All right, we've done the top, we've done the middle, now we're going all the way down. Welcome to the bottom of the barrel. And down here, the rules of the game get turned completely upside down. What's left down here is basically the gunk. It's this thick, heavy, leftover stuff called residue, or res for short. And for a refiner, this isn't a product they're excited to make. It's not a profit center. It's a problem. It is quite literally a liability they have to figure out what to do with. Get this, that profit margin, the crack spread for this stuff, it's often negative. Think about that. A refiner can actually lose money on every single barrel of this heavy fuel oil they're forced to make. They could pay $80 for a barrel of crude oil, and this stuff that comes out the bottom might only be worth $75. It's an incredible economic challenge.
So this creates a major fork in the road. What do you do with this liability? Well, if you're a simple refinery, you don't have much choice. You just have to sell it at a discount, take the loss, and move on. But if you're a complex refinery, you make a huge bet. You invest billions of dollars in massive equipment, things called cokers and hydrocrackers, that can literally break apart those heavy, useless molecules and upgrade that liability into more of the good stuff, gasoline and diesel. And that really brings us to the heart of it all, doesn't it? The entire business of refining is just one big, constant, incredibly high-stakes balancing act. When you boil it all down, the logic is pretty clear. First, you maximize the moneymakers at the top, like gasoline. Then, you accommodate the inflexible but essential products in the middle, like jet fuel.
And finally, you do everything you possibly can to minimize the financial drag from that liability at the bottom. And you've got to do all of that while the market is constantly changing. It's a relentless optimization problem.
So, from that high-tech cocktail of gasoline at the top all the way down to that problematic gunk at the bottom, every single layer of that barrel tells a story about how our world works. It's a perfect reflection of our global economy. But that economy is changing, right? Which leaves us with the big question. As we look to the future, which one of these products is going to tip the scales for good?